What if the very foundations of our civilization, the materials we've used for millennia, stone, concrete, steel, were replaced by something that grows? What if the future of building wasn't about mining quarries or smelting metal, but about cultivating a living organism in a lab? This isn't science fiction. This is the quiet, powerful network beneath our feet, the hidden genius of the fungal kingdom. We're talking about mycelium, the root structure of mushrooms, and its potential to revolutionize how we build our world. Stay with us, because what we're about to show you could change everything you think you know about homes, skyscrapers, and even entire cities. To understand myco-materials, we have to go back to the source, mycelium. Imagine an intricate, branching web of threads. That's what mycelium is. It's the vegetative part of a fungus, a biological superglue that seeks out and binds organic matter together. In nature, this is its job. It decomposes dead wood and leaves, recycling nutrients back into the ecosystem. But what if we could harness that power, that incredible binding strength, and use it on a grand scale? The process is surprisingly simple, yet profoundly innovative. Scientists take a substrate, which is essentially agricultural waste like sawdust, straw, or corn husks. They place this waste into a mold, shaped like a brick, a panel, or anything else you can imagine. Then they introduce the fungal spores. This is where the magic begins. Over a few weeks, the mycelium works its way through the substrate, growing and interlocking its threads, consuming the waste as food. It fills every nook and cranny, creating a dense, lightweight, and surprisingly strong composite. Once the desired shape is fully colonized, the material is heat-treated to stop the growth, killing the fungus and leaving behind a stable, inert block. The result? A myco-material that is grown, not manufactured. So, what are the properties of this grown material? For starters, it's incredibly lightweight. A mycelium brick can be up to 10 times lighter than a clay brick of the same size. This makes transportation easier, reduces the load on a building's foundation, and makes construction safer and faster. But the benefits don't stop there. This material is a phenomenal insulator, both for heat and sound. The porous structure of the mycelial network is a natural trap for air, which means homes built with myco-materials could be significantly more energy efficient, staying warmer in the winter and cooler in the summer. Think of the savings on your energy bill. And here's one of the most surprising facts. Myco-materials are naturally fire-resistant. They don't ignite or spread flames in the same way wood or other traditional materials do. When exposed to fire, they simply char, forming a protective layer that insulates the core. This is a crucial safety feature that's inherent to the material itself, no chemical treatments required. One of the greatest challenges of our time is waste. The construction industry is a massive contributor to landfills. Concrete, steel, and other materials have an end-of-life problem. But myco-materials offer a beautiful, elegant solution. They are completely biodegradable. When a building made of myco-materials is no longer needed, its components can be broken down and returned to the earth. They're not just waste, they're compost. They nourish the soil, completing a perfect circular economy. We take agricultural waste, we turn it into a building, and when that building's life is over, we return the materials to the earth to grow more crops. It's a truly regenerative process. Myco-materials are already making an appearance in temporary structures and architectural installations around the world. Projects like the Hi-Fi Tower in New York and the myco tree show us what's possible. But can we really build a full-scale home, a permanent structure, out of fungi? The answer is, we're working on it. The primary challenge is strength, particularly for load-bearing walls. While myco-materials are strong enough for insulation, panels, and furniture, they often lack the compressive strength of concrete or the tensile strength of steel. But researchers are already experimenting with new techniques to address this. By incorporating other natural fibers, or by combining mycelium with other materials in a composite, they're creating materials that can rival conventional building supplies. Furthermore, there's the issue of water resistance. Mycelium is a fungus, and fungi thrive in damp conditions. While the heat-drying process stabilizes the material, it requires a robust exterior envelope to protect it from moisture. This isn't an insurmountable challenge. Traditional wooden homes also require careful weatherproofing, but it's a critical factor in the design and construction of myco-buildings. Imagine a future where buildings aren't just inanimate objects, but a part of the living ecosystem. A future where our homes can be grown to fit the landscape, with unique, organic shapes that are impossible to create with conventional materials. This is the promise of myco-materials. It's not just a new material, it's a new architectural language. A way of thinking about building that puts nature, sustainability, and our planet first. From the microscopic threads beneath the forest floor to the foundations of our future cities, mycelium offers a path forward. A path away from carbon-intensive manufacturing and towards a regenerative, bio-based world. We are just beginning to tap into its potential, but one thing is clear: the future of building is alive, and it might just be growing right outside your door.